So there's this cool thing that's been making the rounds recently, which is called MCP, or Model Context Protocol. And essentially that's kind of like a standardized way of integrating LLMs with other applications. And to me, that sounds like a pretty intriguing concept, right? Because it means that you can get an AI tool that's running on your computer to control other software and maybe even hardware as well. And since some of our wonderful folks at JetBrains have even built the official SDK for working with MCP in Kotlin, I decided it would be great to kind of take a look and see what all that looks like. Because one of the things that I've always wanted to do was to go to one of my AI tools and tell it something like, make my room look vaporwave. And then have that figure out the fact that I have some smart lights in my room and actually change them to colors or vibes that match what I have in mind. Something like that. So how will we go about building this? Well, let's rewind a little and see how that is actually implemented. To get us started just a little quicker, I have set up a basic project structure here with Kotlin on the JVM, already setting up the serialization plugin, the Model Context Protocol SDK for Kotlin, and some Ktor client dependencies as well. Okay, here's the game plan. First of all, we need to figure out how to control these lights that are in my room. Once we've done that, we also need to somehow expose that functionality through MCP so that we can take a client, for example, Claude Desktop, and we can actually interact with it. So let's get to the point where we can control the lights really quickly so that we can get to the fun part with MCP. So the lights that I have in my room are hue lights, which luckily have an API. We can see that one right here. They have some instructions, and then you can somehow access devices, retrieve them. You can also control them. And here's a color chart, which I guess will become relevant as well. So we don't need to wrap the entire hue API in order to get some basic light controls going. So let's actually first of all figure out the interface of the functions that we actually need. And let's just write those down for a start. Let me create a new package here. Call this hue client. And we will just have a hue client file here, which will have an interface called hue client. Right. Well, so what do we need? Well, first of all, we need to somehow be able to authenticate against the hue bridge, which is kind of the control device in charge of controlling the actual lights. So we need some sort of function to authenticate ourselves. Well, the hue client. Judging by the documentation, that typically takes an app name. And it also needs some credentials. Now, since this actually requires me to like physically press a button on the device, I've already done that previously, so we don't really have to deal with that right now. We are just going to give this function a credentials path, which is just going to be a string. And then off camera, I'm just going to quickly add my credentials as like a TXT file into this project. So now we have the credentials here as well, and this will just take the credentials path. What else do we need to do? Well, we need to be able to find the lights in my room. So like find light IDs for room. In this case, I would like to have the room name, and that should return me some sort of list of IDs. Well, and then we'd also need to actually control the lights. So we actually need to set the light state. And looking at the documentation here, that first of all takes a light ID, then that can determine whether or not we want it to be on. Brightness seems correct, but in fact in the API that's a double. Then we have the color gamut in the X coordinate, which is a double. We have the same in the Y direction, and we have the dimming, which is also a double. And actually all of these are nullable because they are not strictly required. All right, so now we would typically sit down with Ktor on the one side, documentation on the other side, and just implement this interface. Since this is a very mechanical task, I actually don't want to do this myself right now. So here's what we're going to do. Because I have Junie installed right here, which is an AI agent that we are building at JetBrains. And this seems like a perfect task for Junie. So here's what I'm going to do. I am just going to create a quick directory here called Junie. And in here, I'm just going to create a hue getting started.txt file. We don't need to add this to Git. Now we'll just take a look here at our getting started documentation. I'm just going to grab this, all of it. We don't need that anymore. And I'm just going to add it to this txt document. All right, let me quickly type out the task for Junie here, and then we'll talk about it. So here's what I came up with. I want Junie to create a client to control my smart lights, right? It should implement the Hue client interface. I'll tell it where my credentials are, which is credentials.txt. I'll also tell it where my physical Hue bridge actually runs, like the device that controls these. And I'll also tell it that the room that I am in right now has 4 lights. Well, there's 3 of them right there, and then one that you can't see. Just to make sure that it really stays focused on this task, I'm also going to tell it that I already have all the dependencies set up. And here's something which I figured would be clever. We'll tell it to write an integration test that actually tests against the office lights, which means if it ever makes a mistake, the bridge will tell it that a request was, for example, malformatted. Great, with that, I think we can send it off to Junie and I can just refill my cup of tea for a second here. Hi, post-production Seb here. So while I am over in the kitchen making some tea, Junie is getting to work. As you can see, it starts by understanding what's going on in the project, and it also reads the Hue Getting Started document that outlines how to implement the API client. And from here, Junie writes an implementation, it writes an integration test, and then it runs that integration test. So Junie can actually autonomously validate that it did the right thing, which it actually didn't do on the first try. And you can see that in the test output window. So it makes some changes that also result in a failure of the test. It adds a little bit of debug logging to understand what exactly is going on, in pretty much the same way that I would probably do it. And finally arrives at a solution that actually passes the test. And with that, Junie has done in a little over 3 minutes what would have taken me a little longer and would have quite frankly been quite boring to do. All right, back to recording, Seb. All right, Junie says it's done. And it had a test that passed, which I can run right now. And that turns off the lights and turns them back on. And turns them a different color. And turns them back to white. Nice, okay. Well, that's pretty much exactly what we needed. Great, so 1 teacup later, we can actually move on to MCP. Of course, in any real project, you would conduct a thorough review of the code that was generated here. We can still take a quick look. By reviewing the code, we might actually still learn something. For example, the fact that Junie actually correctly had to disable the SSL certificate verification. That's because this is a local device running on a local IP address, so it doesn't have a domain attached to it where this verification could otherwise work. Then we can, of course, see if the code that was generated was to our liking. And if not, we could either ask a follow-up question to Junie or just make the changes directly. For example, if I were to write this code, I would probably not create the JSON objects ad hoc like Junie did here using the build JSON object builder function, but instead I would have like @serializable data classes. Again, Junie could change that for us, but that's not really why we're here. We're here to learn about MCP. Let's start building on that. I'm just going to quickly commit what we have here, and then I'm going to create us our new package called Hue MCP. And now it's time to build the actual MCP server. Like I said when we started, I already have the Kotlin SDK for the Model Context Protocol set up that is built by a couple of our wonderful JetBrainers, which means we can actually start writing code right now. The first and most important thing is actually creating a server. That would be of type Model Context Protocol Server. And since this is going to be quite a long definition, I'm just going to create ourselves a little function that would do exactly that and gives us one of those things back. We then actually also need to decide how our server is going to communicate with the MCP client, like for example, Claude Desktop. The 2 ways of doing this that are outlined in like the MCP specification, as far as I can tell, are server-sent events and standard I/O. Server-sent events are not supported in Claude Desktop at the moment, so we're going to go with standard I/O. So we can define ourselves a standard I/O server transport, which is just a standard I/O server transport. That needs 2 things, an input stream and an output stream. And since we're doing standard I/O, those are just our regular old streams. That's system in as a source, which will buffer. And as the output, we have system out as sync. And that one's also buffered. there's something that's really, really important to remember when we are using standard.io as the transport layer, which is that we can't do any fun print line debugging, because anything that you print line will go to system out. So it will be received by the client. The client will get confused because it won't understand the type of message that you send. So before I forget that, let me actually make sure that any debug, like print line statements that were added to the Hue client implementation are removed. There's a couple of them. I'm just going to get quickly rid of them. All right, all gone. I just know that otherwise I'm going to forget that. Right, now it's time to actually start that server. So let's do server.connect via that transport. As we can see, this is a suspending function. So I'm actually going to wrap this into a run blocking block. And this should typically be everything, but the current version unfortunately doesn't quite wait on the connections yet. So we need to do a tiny little workaround. We'll simply create a new job, and then with our server, we will register an onClose callback, which completes that job. And that means that we can wait for this job. This is just to keep the server alive. Right, that's the basic mechanics out of the way. Now it's time to actually specify what it is that our server is doing. So the server that we will return in the end is of type server, and that is what we will return. The server needs a server info, which is of type implementation, and options. And we can fill that in like a form. First, we need to provide a name, Hue Office MCP. And that also specifies a version, 1.0.0. We also need to specify the options. Now, one of the things that these outline are the capabilities, because MCP servers can actually expose a number of different capabilities. The one that we're most interested in are tools, so things that can actually be used by the model. But there are also other things that can be provided via MCP, like resources, which can be read for context by an LLM, or specific prompts. In our case, we just want our capabilities to specify the server capabilities of type tools. So here we are simply saying that we are offering tools to the LLM, and we can feed that back in as well. Great, so now let's build the tools that we want the AI to be able to invoke. And those will pretty much closely mirror what we have in our Hue client. Specifically, we want our assistant to be able to find light IDs for a room and also set their state given all of these properties. So let's add some tools. To do that, we say server.addTool. And then we have a couple of things to specify. First of all, a name, like list office light IDs, and a description. So this is a lambda that will be invoked whenever the LLM uses this tool, and we will get whatever the LLM sends over as a call tool request, and then what we are expected to return is a call tool result. So for listing these office lights, we want to create a call tool result. That one takes a content, which is a list of prompt message content. In our case, that would just be some text content. And that can just be any kind of string. So if we had a Hue client, which we can now just create very quickly from the Hue client implementation, and we can make sure that we actually only depend on things from the interface. We can go into our Hue client and we can find lights for room, and we will hard code the name office here. And then we will indeed join this just to a string. Well, one of the blessings and curses of working with LLMs is that the API surface is somewhat squishy. Like, I don't really need to provide a specific schema or a specific JSON format. I can just kind of throw them in a way that the LLM will probably understand. Comma-separated list seems good enough. What we shouldn't forget is to authenticate before we do all of this. And since this is a one-off operation before we can do anything reasonably, I'm just going to throw this into a run blocking. You are free to disagree with me on that decision. Great, so now we have a first tool set up. Now we actually need to be able to control things. And that is just a second tool. So we'll add another tool. Call that one setLightState. This is also a great place to give a little bit of extra information. For example, when I tested this manually, I was a little confused about the fact that while the brightness is a double, it actually goes from 0 to 100. So we can even add here that brightness goes from 0 to 100. Great. Once again, we need to specify our lambda, which then hopefully at the very end just creates a call tool result. and we'll just tell it the changes have been applied. And the implementation of this tool is slightly more complex because while last time we kind of just expect a call without any parameters, it's different now. Now, all the kind of things that we have in our Hue client when we call setLightState, all of these properties, they somehow need to come from the LLM. The way we tell the LLM that these are the things that are available is called an input schema. And that is something that we can add to the definition of our tool, which is really just a tool.input. And this one, as its properties, just takes a JSON object that kind of describes as a schema what kind of data should be able to be passed in. So we can just say build JSON object since we have Kotlin X serialization configured in this project. And then we have a couple of different elements that we want to put in here. I'm going to import the one that's a string to string key here. It's really just a couple of properties, right? So we have on, we have brightness, which is a number. Color gamut X, Y, and dimming also all seem correct. However, we shouldn't forget about the light ID. Great, with the schema in place, we can pass it to the server add tool as one of the properties, just the input schema. We can actually rename this and call it setLightState input schema. Let's wire these things back together. We receive the input arguments as a JSON object. So we can actually just extract these out. First of all, the ID is input arguments, and then we would get those at light ID like we specified right here. And that is a JSON primitive whose content we're interested in. The ID is the only one that's non-nullable, so we're just gonna use the bang bang operator here as a quick shortcut. And we need to do the same for the other properties, though these will be optional. So on is indeed the arguments JSON primitive Boolean or null. The brightness is a double, and the color gamuts are indeed also doubles. Remains as dimming, and we're done. Now let's thread this into our actual Hue client, which is just a single line where we pass all of these operations in. And after that, we're done. Okay, so now that we've actually implemented it, it's time for us to package all of this up in a way that we can test it from an inspector, for example, or then also just call it directly as an MCP server from one of our desktop clients. Packaging all of this up can be done pretty quickly via the application plugin in Gradle. So if I just import that one real quick, I'll be able to specify an application block, and here I can set the main class. In our case, that would be our MCP server. So I think I should be able to just grab myself, for example, here, the main function, and I'll copy a reference to it. Under distribution, the application plugin adds something called install dist. And that one creates in your build folder an install directory, which under bin provides a shell script and a batch script to execute your program. So for example, if I were to run this HueLight MCP, it would actually run the project, and it would then promptly explode because I'm doing it from a different working directory where the credentials.txt is not present. There are, of course, nice ways to fix this, but since we are kind of like in a development cycle here, I'm going to cheat a little bit, and I'm just going to grab myself the absolute path so that we don't have to spend too much time on this. With that out of the way, we can see that it's now waiting for input from the server. To get some insights into our own application, we're going to be using the MCP inspector, which we can find on GitHub. That's a tool for like debugging and testing things. Startup is very easy. We can just grab this npx command. We don't really care about the node part at the back there. We can run this, and then that starts as a local MCP inspector. Over here, it expects the command. So this is where we pointed to the startup script. We will just give it the absolute path to that, and then we can hit connect. And now our MCP server is running. So good job us. We can actually hit something like list tools. We can run the list office light IDs tool, grab ourselves one of these IDs, go to set light state, and maybe set on to false. And then if we run that, well, that was the one light that's off screen. So let me do that again. We'll grab ourselves the second ID and setting that to false. Turned off one of the lights. Very nice. It's getting a little dark in here, so let's turn that one back on. The only thing that really remains is wiring it up with Claude Desktop, for example. So here is Claude, for example. And if I just open the settings, here they are. There's a developer section where we can edit specialized things for the MCP service. So you can see in my local installation here, I actually already have one MCP server configured, which is JetBrains. Because that's right, your JetBrains IDEs can actually also act as MCP servers for tools like Claude, meaning that Claude can interact with your IDE. For example, we might ask Claude a question about our integration test. Let's ask it in the integration test, what colors are the lights set to? And this will now use the JetBrains MCP integration to interact with our code base. And it can see that it can read the code that's in our project, navigate it, find things, and could even write some code as well. So now, onto our own integration. Back at the settings, I'm just going to edit this configuration. So time to specify our own MCP server. We can just kind of use this as a template. In our case, we'll call it something like QMCP. We'll have to provide a command. In this case, that is once again the absolute path to our startup script. And we don't need to provide any kind of arguments. And I'm just going to restart the Claude Desktop app. And from there, it's as easy as setting my office lights to vaporwave colors. First, it knows that it needs to figure out which IDs there are, so we'll allow that. It calls into our tool, gets back the correct IDs, and then we'll allow it to set the light state. And just like that, lights change color. Gorgeous. Or maybe we feel more like jungle colors instead. What about a mango? So as we have seen, it does not take a lot to write your first MCP server using Kotlin, especially if you already have the rest of the system existing. Here we just delegated the implementation of the entire API client to Junie. But I hope that you see that if you have an already established application, that the Kotlin SDK for MCP makes it quite easy to integrate with AI tools. If you want to learn more, we'll include a whole bunch of relevant links down in the description. And that will also include the source code for this very project, so you can take a look and maybe fix some of the things where I took a shortcut.